Hello, my name is Courtney Paholski and I'm a PhD student from Penn State University. Today I would like to discuss pellet quality and its effects on bird performance, focusing specifically on hen turkeys.
I will begin with some background information, and that is that modern commercial broilers are fed predominantly pelleted diets because of the known improvements to performance and efficiency. The improvements in performance have been attributed to decreased feed wastage, selective feeding, and ingredient segregation. Now, birds also spend less time and energy consuming a single pellet compared to multiple mash feed particles. These performance benefits are well documented, and in fact, we have known about these improvements for several decades. Patton and Jensen were pioneers of this type of research with their reports of improved growth and feed efficiency for birds fed pelleted diets. Now, we can increase the magnitude of these performance benefits by improving pellet quality. One strategy to do so is to increase the percentage of pellets in the diet. However, there are multiple factors that influence pellet quality, and thus there are many techniques that can be utilized. Presented here are data that shows how marginal improvements to pellet quality can yield benefits to feed efficiency. When considering broilers, in 2015, Glover and colleagues reported a 3-point improvement in feed conversion ratio when pellet quality was improved by 30%. Lemons and cohorts conducted similar work and reported a 5-point improvement in feed conversion ratio. Then, in 2017, Glover et al. Found that more drastic improvements to pellet quality resulted in a 6-point improvement in feed conversion ratio. These data suggest that more drastically increasing the percentage of pellets in the diet amplifies the magnitude of improvements to efficiency. Now, it is worth noting that a majority of pellet quality research uses the broiler chicken model, and there has not been much focus on turkeys. Broiler chickens are smaller and have shorter grow-out periods compared to turkeys, so we cannot assume that turkeys will respond to pellet quality in the same manner. In 1982, Proudfoot and Hulan suggested that turkeys are more sensitive to pellet quality improvements compared to broilers. It wasn't until 35 years later that this idea was revisited by Boney-Lamp and Mortz, who compared ground pellets to various pellet qualities and found that more drastic improvements in pellet quality yielded additional feed conversion ratio benefits. However, it is difficult to drastically improve pellet quality at the feed mill due to throughput demands. Thus, we must explore the effects of modest improvements in pellet quality obtained using techniques practical to the commercial industry. And this idea was applied to the current study, where we considered how marginal improvements in pellet quality would affect hen-turkey performance and processing variables. We hypothesized that modest improvements in pellet quality would result in enhanced hen-turkey performance, and the objective of the study was to simply determine the effects of pellet quality to hen-turkey performance and processing parameters. Moving on to the experimental design, a total of 448 Nicholas Select hen turkeys were randomly distributed across 16 floor pens with 28 hens per pen. 2 pellet quality treatments were arranged in a randomized complete block design with 8 replicate pens per treatment. The experimental unit was thus considered a pen containing 28 hen turkeys. Hen turkeys were placed on a 7-phase commercial feeding program, and these birds were provided a common starter crumble from day 1 to 28. For each feeding phase after day 28, diets were nutritionally similar, varying only in pellet quality. Therefore, day 29 to 112 was used as the true experimental period for this study. Depicted here are the ingredients and calculated nutrient percentages for each of the experimental feeding phases. These are all commercial corn, soy, wheat-based diets where wheat was included at 20% to create really high-quality pellets. Diets for all phases were formulated in accordance to AVGN hen turkey specifications. Now presented here are the analyzed nutrient values and pellet quality descriptive data for the Finisher 3 diet phase. As you can see, the improved pellet quality and poor pellet quality treatments are nutritionally similar. They differed only in pellet quality as described by the pellet-to-fine ratios and physical pellet durability tests. Now I will discuss feed handling and pellet quality manipulation. Feed was delivered to Penn State and augured into a bulk bin. It is important to note that a single high pellet quality diet, averaging 90% pellets across all diet phases, was manufactured in coordination with a commercial mill. I want to stress that this high quality feed was achievable using commercial feed manufacturing techniques. Now, half of this feed was manipulated in order to create the poor pellet quality treatment, which will be explained here shortly. The feed was systematically augured out of the bins and evenly split into two allotments, IPQ and PPQ. Therefore, both feed allotments were produced at the same time, and this systematic approach to feed sacking allows both feed allotments to be similar. Therefore, any feed particle segregation in the bin was factored into both allotments for each feeding phase. In addition, 4 systematically selected 50-pound feed bags were removed from each allotment during sacking. These bags were used for pellet-to-fine ratio determination using a modified particle size separator. For each of the experimental diet phases in this study, the goal was to reduce the pellet-to-fine ratio by 30% to create that poor pellet quality treatment. Calculations were performed to determine the amount of pellets from the poor pellet quality feed to be ground. Prior to the study, an internal experiment was conducted to understand pellet degradation from mixing. Thus, we factored in that mixing for 90 seconds degrades the percentage of pellets by 2%. Therefore, our calculations only considered a 28% reduction in pellet-to-fine ratio. After calculations were performed, a portion of the PPQ feed was sifted using a modified particle size separator fitted with a number 5 ASTM sieve to separate the pellets from the fines. Calculated amounts of the sifted pellets from the poor pellet quality feed were then passed through a hammer mill in order to create fines. Resulting fines and remaining poor pellet quality feed were then layered in a mixer and mixed for 90 seconds to create the final poor pellet quality feed treatment. Both performance and processing metrics were measured during this experiment. At 28 days of age, the poults were weighed to ensure similar body weights among pens. This allowed us to consider pellet quality effects during the treatment period from weeks 5 through 16. Feed intake was calculated for each feeding phase, and pen weights were recorded at 4-week intervals through 16 weeks of age. Finally, at 16 weeks of age, 1 bird per pen was randomly selected for processing yields. Regarding statistical analysis, all data were analyzed using the GLM procedure of SAS, where one-way ANOVA tests were performed. Fisher's least significant difference test was used to further separate the means, where alpha was less than or equal to 0.05. I will now move on to the results from this experiment. First, when considering data from the overall period, we see that feed intake, live weight gain, and body weight were not affected by pellet quality. However, numerically, it is apparent that hens fed the poor pellet quality feed exhibited both slightly increased feed intake and reduced live weight gain. Now let's consider feed conversion ratio. This slide shows that when hens received pelleted feed from weeks 5 through 12, FCR was not different. However, when we consider weeks 5 through 16, we see that providing improved pellet quality feed improved FCR by more than 10 points. To elaborate on the data from the previous slide, we decided to look at weeks 5 through 12 performance because this period lined up with light hen turkey production, while weeks 5 through 16 lined up with heavy hen turkey production. As you can see here, In 2016, a total of 31 million light hens were produced, averaging 11 pounds in body weight. 73 million heavy hens were also produced that year, averaging 21 pounds in body weight. Therefore, heavy hens make up a majority of total hen turkey production, and so heavy hen producers may want to focus on pellet quality improvements in order to maximize feed efficiency. Next, in order to better understand the week 5 through 16 data, we decided to look at hen performance from weeks 13 through 16. This bar graph here shows that providing improved pellet quality during this time improved FCR by 23.7 points. Therefore, this data suggests that optimizing pellet quality during the latter phases of production, when feed intake is high and pellet quality is generally low, may improve hen feed efficiency. If we consider processing yields, we see that pellet quality had no effect on chill carcass yield nor breast yield at 16 weeks of age. However, merely 8 hen turkeys per treatment were processed, and thus a larger sample size is required to draw significant conclusions from these data. Lastly, economic analysis was performed using feed intake and feed cost values for each diet phase per treatment. Although no statistical differences in feed intake were observed among the treatments during the overall period, this descriptive economic analysis shows that overall, 23 cents were saved per bird by feeding the improved pellet quality feed. Now, I would like to conclude this talk with a take-home message, and that is that positive effects from feeding improved pellet quality feed to hen turkeys is dependent upon target market weights. As we observed in the current study, improved pellet quality feed showed the greatest potential for feed efficiency improvements in the latter phases of production. With that, I would like to thank you for your attention, and I would also like to acknowledge Aviagen for funding this project.